Hello, welcome to Introduction to Computer Architecture. My name is David Black-Schaffer, and I'll be your instructor for this course. The first part we're going to start off today is an introduction about the course and the logistics of the course. So let's go ahead and get started. Today we're going to talk about the course, prerequisites, and what you should expect to find in the course. We're going to talk about what is computer architecture, and very importantly, why should you care? And these are both questions that you should bring up whenever you start a new class. What is it you're going to learn in this class, and why is it important to learn it? Then we're going to talk about course logistics. In particular, I'm going to talk about feedback we got from last year, changes we're making this year, and then all the details of gradings and assignments and sort of important stuff that you need to know but isn't really part of the course. So let's get started talking about the course. So this is an introductory course in computer architecture. This is not for IT and DV students. So if you're in either of those programs, you should be taking the computer architecture course in the spring. The prerequisites for this course are basic programming experience in an imperative language like C or Java. That is not a functional programming language. So we expect you to be familiar with for loops, if then else, variables, and accessing memory arrays. There are two main topics that this course is going to cover: how a computer is built and how the computer is controlled. When we talk about how the computer is built, we're going to start off with logic, the very low level, then build those up into circuits, and then talk about how the data path is built. And the data path is where the actual computation goes on. When we talk about how a computer is controlled, we're going to start with instructions, figure out how the instructions influence the microarchitecture, talk about the instruction set architecture, or ISA, and do this all in the context of assembly language programming. The contents of this course, in general order, are starting out with MIPS assembly language. This is going to be your first lab assignment, and this is what we'll spend the first 3 lectures working on. Then we're going to talk about logic design and how you use this to build a processor. We're going to start out with a single cycle processor and then go into pipeline processors. We're then going to spend a lot of time talking about input, output, and memory, in particular caches and virtual memory, and see how they play a role in performance and security. And then finally, we're going to finish up this class talking about parallelism and a roofline method. The roofline method is a really good way to look at performance of a program and understand what the performance is being limited by, if it's limited by the hardware or the program. So when you see something like this, there's some questions you should be asking yourself. And the first one is a pretty obvious one. Why should you care about this stuff? There are only a few companies in the world that design processors. Almost everybody just buys a processor from Intel or AMD and writes their software on it. So why are we going to focus on how you design and build a processor in this class? The second question is, why are we using MIPS? None of you own a MIPS processor or a MIPS computer, so why aren't we working on something more common that everybody has? Well, the answers to these 2 questions are important. And the first one is, why should you care about this stuff? Well, understanding architecture is essential for understanding performance, and everyone cares about the performance of their code. And why aren't we using MIPS? Well, the reason we're using MIPS is because it's simple. x86, which is what everybody has in their laptops and desktops, is really complicated and rather ugly, and so by sticking to MIPS, we make it easier for you to learn the important parts of this class. So what are the learning objectives for this class? Well, the most important one is to understand the functionality and operation of a computer, and this includes basic parts such as the processor, memory, and input and output. We want you to be able to reason about performance, that is, to understand how does caching or pipelining affect performance, and be able to model out what that performance will do, and be able to figure out what's better and what's worse. We want you to be able to understand the hardware-software interface. That is, when you write code, how does that code interact with the hardware to get stuff done? And finally, be able to understand and write assembly language programs, because this is a really good way to understand what's going on in the computer at a low level and bridges between the high-level code that you write and the low-level details of the computer.